Settle into the sleepy mind channel, and tonight we will explore stars. As you settle into a comfortable position, allow your surroundings to become quiet and steady, with nothing demanding your attention. There is no need to focus on anything specific, only to listen as each idea unfolds gradually, one after another, in a calm and continuous way. Imagine standing beneath a clear night sky, where the air is still and the darkness stretches outward in every direction. Above you, there are small points of light scattered across that darkness, each one steady and distant. They may appear close together, almost as if they have been placed there carefully, yet each of these lights is separated by distances that are difficult to fully imagine. Some are relatively nearby, while others are so far away that their light has been traveling for years or even longer before reaching you. One of these lights is much closer than all the others, even though it does not always appear in the night sky. That light is the sun. It is a star like the others, but close enough that its light fills the sky during the day, warming the surface of the earth and making life possible. Without it, the world would remain dark and cold, and the steady conditions that support living systems would not exist. The warmth you feel during the day and the light that allows you to see both come from this single nearby star. When you look at the other stars at night, the light reaching your eyes has traveled across space for long periods of time. This means that you are not seeing those stars as they are now. Instead, you are seeing them as they were when that light first began its journey. In some cases, the star you are looking at may have changed, or may no longer exist in the same form, yet its light continues to move steadily through space until it arrives here. The number of stars that can be seen with the human eye is only a small portion of what is actually present. Many more stars exist that are too distant or too faint to be visible without instruments. Each of these unseen stars is similar in nature, a distant source of light and energy, existing far beyond the immediate reach of our surroundings. Together, they form a vast system that extends in all directions, far beyond what can be observed directly. As you remain here, with the night sky above, it becomes easier to think of each of these points of light not as small objects, but as distant suns. Each one is a place where energy is being produced continuously, releasing light and heat into the surrounding space. These stars are not fixed in place. They exist in motion, changing slowly across long periods, shaped by forces that act steadily rather than suddenly. In the same way that the sun supports life on Earth, other stars may support systems of their own. Around many of them, planets may be moving quietly, held in place by gravity, circling their star across long stretches of time. These systems remain unseen from here, yet they are part of the same larger pattern that connects all stars across space. As this continues, the night sky becomes more than a collection of distant lights. It becomes a view into a much larger structure, one that is always present, even when it is hidden by daylight. Each star represents a point within that structure, connected through distance and time. Looking upward is not only a way of seeing what is far away, but also a way of looking into the past, observing light that has traveled steadily across space to reach this moment. With this in mind, we can begin to explore what stars are, how they form, and how they continue to exist across long periods of time. Imagine holding in mind one of those distant points of light, not as something small, but as something vast and active, existing far beyond the scale of anything nearby. A star can be understood as a large sphere made of gas that has become so hot that it begins to glow. Even though it appears steady from a distance, it is constantly active within, shaped by forces that balance against one another in a stable and continuous way. At its most basic level, a star is made mostly of hydrogen and helium, the simplest and most abundant elements found throughout the universe. These gases do not form a solid surface. Instead, they behave more like a deep and continuous atmosphere, where everything blends together without a clear boundary. If you could move closer, there would be no ground to stand on, only layers of gas that gradually become denser as you move inward toward the center. As you move further into this structure, the sense of depth increases. The outer layers are more spread out, while the inner regions become more tightly packed. This gradual change is not sudden, but steady, like moving deeper into water where the pressure slowly builds. The deeper you go, the more the material presses inward, guided by a force that is always present. What keeps all of this material together is gravity, which pulls every part of the star inward at the same time. This pull is steady and constant, drawing the gas toward the center from every direction. It does not act in bursts or sudden movements, but in a continuous way, always working to gather the material into a single unified form. As more material is drawn inward, the pressure increases, especially in the deeper regions. It can help to imagine a slow and steady squeeze from all sides, where everything is being gently but continuously pressed toward the middle. This inward pull is balanced across the entire star, creating a sense of structure even though there is no solid surface. If gravity were the only force present, the star would continue to compress further and further, becoming smaller and denser without stopping. The material would move closer together, and the center would grow increasingly compact. However, something else takes place deep within the center that changes this outcome and prevents the star from collapsing inward. At the center of the star, the temperature rises to levels far beyond anything experienced on Earth. The pressure also becomes extremely high, forcing atoms close together in a confined space. Under these conditions, hydrogen atoms begin to combine. This process is known as nuclear fusion, where smaller atoms join together to form a larger one. In this case, hydrogen is gradually transformed into helium. While this change happens on a very small scale at the level of individual atoms, the number of these reactions taking place at the same time is immense. Because of this, the total amount of energy released becomes very large, even though each individual reaction is small. This energy begins in the center and then starts to move outward, passing through the surrounding layers of gas. The movement is not fast or direct. Instead, the energy interacts with the material along the way, transferring gradually from one region to the next. It can take a long time for this energy to reach the outer layers where it can finally escape. As this energy moves outward, it creates a steady pressure that pushes against the inward pull of gravity. These two forces remain in balance, with gravity drawing material inward and energy pushing outward at the same time. The star exists in this balanced state, maintaining its size and structure, because neither force fully overcomes the other. This balance is not fixed in a rigid way, but constantly maintained. Small changes within the star are adjusted naturally as the forces continue to interact. The result is a stable system that can exist for very long periods, continuing its internal processes without sudden disruption. The light and heat that leave the surface of the star are the final result of this ongoing process. What appears as a steady glow is actually energy that has traveled from the center, moving slowly outward until it reaches the outer layers where it can move freely into space. By the time this light leaves the surface, it has already passed through many layers within the star. It can help to imagine warmth spreading from the center of a large space, moving outward in all directions. As it travels, it passes through layers, transferring energy step by step until it finally reaches the outer edge. In the same way, the energy within a star moves outward through its layers before becoming visible as light. Even though this process is continuous, it remains calm and steady rather than sudden or uneven. The star does not surge or flicker in a noticeable way from moment to moment. Instead, it maintains a consistent output of light and heat, the result of countless reactions taking place deep within its interior. In this way, a star can be understood as a system that maintains itself through balance. Gravity gathers and holds the material together, while the energy produced through fusion prevents it from collapsing further. As long as both of these processes continue, the star remains stable, holding its shape and continuing to produce light and heat across long periods of time. Although this process takes place on a scale far beyond everyday experience, the idea behind it can still be followed step by step. A star is a place where energy is constantly being created and released, held together by gravity and sustained through a steady internal process. Even from a great distance, the light that reaches you is directly connected to what is happening deep within the star. As you hold this image in mind, it becomes easier to think of each star not as a distant point of light, but as a complete and active system. Each one exists in balance, continuing its quiet and steady process, releasing light into the surrounding space across long stretches of time. Imagine now shifting your attention from distant stars in general to one that is always present, even when it cannot be seen at night. This is the Sun, the star that is closest to Earth. Although it may feel familiar because it is part of daily life, it is still a star in every sense, sharing the same structure and internal processes as those faraway points of light, only experienced from a much closer position. Because the Sun is so near compared to other stars, it appears much larger and brighter in the sky. The other stars remain small points of light because of their distance, while the Sun fills the sky with steady brightness during the day. This difference is not because the Sun is uniquely special among stars, but because it is close enough for its light to arrive in a concentrated and direct way, rather than spreading thin across vast distances. The energy that comes from the Sun travels outward through space and reaches the Earth in a short amount of time compared to other stars. This energy arrives as both light and heat, creating a steady warmth that can be felt on the surface. It can be understood as a continuous flow, moving outward in all directions, with a small portion of it reaching the Earth and interacting with the atmosphere, the land, and the oceans. This steady flow of energy allows conditions on Earth to remain stable. The warmth from the Sun keeps water in a liquid state across large areas, allowing rivers to flow and oceans to remain active. In the presence of this energy, plants are able to grow, using sunlight as part of their process for producing energy. This supports the broader system of life, where animals depend on plants, and both depend on the steady presence of sunlight. Without this constant input of energy, the surface of the Earth would gradually lose heat. Over time, temperatures would fall, and the balance that supports living systems would shift. The presence of the sun prevents this from happening, maintaining a steady environment where changes occur slowly rather than suddenly, allowing systems to adapt and continue over long periods. The sun is considered a medium-sized star, meaning it sits between the largest and smallest stars found in the universe. Larger stars contain more mass and tend to release energy more rapidly, while smaller stars release energy more slowly over longer periods. The sun exists in a balanced position between these extremes, allowing it to remain stable for billions of years without rapid changes in its structure. Its age is estimated to be about 4.5 billion years. Over this long span of time, the sun has continued the same internal process of producing energy through fusion, maintaining a steady output that has changed only gradually. This long period of stability is what has allowed life on Earth to develop and continue, as the conditions have remained within a narrow and consistent range. The relationship between the sun and the Earth is shaped not only by energy, but also by gravity. The Earth moves in a steady path around the sun, guided by the sun's gravitational pull. This motion is continuous and balanced, with the Earth moving forward while also being gently drawn inward, creating a stable orbit that repeats over time. It can help to imagine an object moving forward while being gently guided in a curved path, never falling directly inward and never drifting away. The balance between motion and gravity allows this path to remain consistent, creating a repeating cycle that continues without interruption. This is the path that the Earth follows as it moves around the sun. Even though the sun is close compared to other stars, its light still takes time to reach the Earth. The journey takes about 8 minutes, meaning there is always a short delay between the light leaving the sun and arriving here. This delay is small when compared to the years or even centuries it can take for light from more distant stars, yet it shows that light always travels across space over time. Because of this, the sun provides a direct example of what all stars are doing. The warmth that can be felt and the light that can be seen are both results of the same process that occurs in distant stars, only experienced at a closer range. This makes it easier to understand that the same type of activity is taking place throughout the universe, even in places that cannot be reached or directly observed. As this continues, the sun can be thought of not only as a familiar presence in the sky, but as part of a much larger pattern. It is one example among many, sharing the same balance of forces and the same steady release of energy that defines all stars. The difference is simply that this one is close enough to be experienced directly, while the others remain far away. Holding this in mind allows a clearer connection between the sun and the other stars that appear at night. Each of those distant lights follows similar principles, existing as a stable system shaped by gravity and energy. The sun is simply the one that happens to be near, making it possible to feel its warmth and see its light in a direct and continuous way. Imagine now moving further outward, beyond a single star, to the places where stars begin their existence. These regions do not appear as bright points of light. Instead, they begin as vast areas of gas and dust spread across space, forming what are known as nebulae. These clouds are not solid or clearly shaped. They are more like a thin, extended mist, stretching across large distances, with material drifting slowly within them. Within these clouds, the gas is not evenly distributed. Some areas become slightly denser than others, gathering more material over time. As this happens, gravity begins to have a stronger effect in those regions, gently pulling the surrounding gas inward. This movement is not fast or sudden. It happens gradually, as particles drift closer together, guided by a steady inward pull that becomes stronger as more material collects. As this process continues, the region grows denser and begins to take on a more defined shape. The material gathers into a central area, forming what is known as a protostar. At this stage, the object is not yet a true star. It does not produce energy through fusion, but it is in the process of becoming one. The gas continues to move inward, increasing both pressure and temperature at the center. It can help to imagine a slow gathering of material, like a gentle settling inward from all directions. As more gas moves toward the center, the space becomes more compact, and the pressure begins to build. The increase in pressure leads to a rise in temperature, as the motion of particles becomes more active within the confined space. As the protostar continues to form, the center grows hotter and denser. The outer layers still consist of gas that is gradually falling inward, feeding the growth of the central region. This stage can last for long periods, as the object slowly builds toward the conditions needed to become a stable star. Eventually, the temperature and pressure at the center reach a point where nuclear fusion can begin. Hydrogen atoms start to combine, forming helium and releasing energy. This marks the transition from a protostar to a true star. The energy produced at the center begins to move outward, creating the same balance between inward gravity and outward pressure that defines all stars. This transition is not marked by a sudden change in appearance, but by a shift in what is happening inside. The object begins to support itself through its own energy production, rather than continuing to collapse under gravity alone. The outward flow of energy slows the inward movement of material, bringing the structure into a more stable state. Star formation does not happen in isolation. Many stars form within the same nebula, creating groups or clusters of stars that share a common origin. These stars may remain loosely associated for long periods, moving together through space as part of a larger structure. In some cases, the formation of one star can influence the formation of others nearby. When a massive star reaches the end of its life and releases energy outward, it can send a wave through surrounding gas. This movement can compress nearby regions, triggering the formation of new stars. In this way, the life cycle of stars becomes connected, with earlier generations influencing those that follow. These star-forming regions can still be observed in certain parts of the sky. One example is found within the Orion constellation, where active regions of gas and dust continue to produce new stars. Although these regions appear faint from a distance, they represent places where the process of star formation is ongoing. As this continues, it becomes easier to think of stars not as isolated objects, but as part of a continuous process. Gas gathers, stars form, and their energy and influence contribute to the formation of future stars. This cycle unfolds gradually across long periods, with each stage connected to the next. Holding this in mind, a star can be understood not only as a source of light, but as part of a larger pattern that begins in quiet clouds of gas and develops slowly into a stable, glowing system. Each star carries with it a history that began long before it became visible, shaped by the gradual movement of material and the steady influence of gravity. Imagine now following a star, not at the moment it forms, but across the long span of its existence, where time stretches far beyond anything experienced in daily life. A star does not remain unchanged. From the moment it begins producing energy, it continues through a steady process that can last for millions, billions, or even longer periods, depending on its size and the way it uses its internal fuel. The length of a star's life is closely connected to its mass, which is the total amount of material it contains. Stars that gather a large amount of material during formation behave differently from those that form with less. This difference may not appear obvious when viewed from a distance, yet it determines how quickly a star uses its energy and how long it can remain in a stable state. In larger stars, gravity pulls more strongly inward because there is more material being drawn toward the center. This creates higher pressure in the core, where the material is compressed more tightly than in smaller stars. Under these conditions, the temperature rises to higher levels, allowing fusion to take place at a faster rate. The star produces energy more quickly, releasing light and heat in greater amounts. This faster release of energy can be thought of as a steady output that is more intense, like a source of heat that is constantly working at a higher level. The energy moves outward through the star, pushing against gravity with greater force. At the same time, the fuel that supports this process is used more rapidly, gradually reducing the amount available over time. Because of this, larger stars move through their lifespans more quickly. Even though they may appear powerful and bright, their internal processes are consuming fuel at a faster pace. Over long periods, this leads to a shorter overall life compared to stars that release energy more slowly. The brightness of the star reflects this higher level of activity, even though it comes at the cost of longevity. Smaller stars follow a different pattern. With less mass, the inward pull of gravity is weaker, and the pressure in the core does not reach the same extremes. The temperature remains lower, and fusion occurs at a slower rate. This results in a steady and less intense release of energy, where the star produces light and heat in a more gradual way. In this slower process, the available fuel is used carefully and continuously. The star does not consume its material quickly, allowing it to remain stable for an extended time. It can help to imagine a steady process that continues without urgency, where each step takes longer to unfold, yet the overall structure remains consistent and balanced. Some of the smaller stars, known as red dwarfs, follow this pattern to an extreme. Their energy output is gentle, yet it is sustained across very long periods. These stars can continue producing energy for spans of time that extend far beyond the current age of the universe, maintaining their steady state with very little change. Stars in general can live for millions to billions of years, depending on their mass and the rate at which they produce energy. Larger stars move through their lives more quickly, while smaller stars extend their existence across far longer periods. This range creates a wide variety of lifespans, all shaped by the same basic processes but unfolding at different speeds. As a star continues through its life, the material in its core gradually changes. Hydrogen becomes less abundant, while helium increases. This change does not happen all at once, but slowly, as fusion continues over long periods. The balance within the star begins to shift as the available hydrogen decreases and the composition of the core evolves. This gradual change in the core affects how energy is produced and how it moves outward. The star adjusts to these changes in a steady way, maintaining balance even as its internal structure shifts. The outer layers continue to release light, while the deeper regions slowly transform, creating a long and continuous progression rather than a sudden change. In this way, a star's life can be understood as a steady unfolding process shaped by its initial mass. From the moment it begins producing energy, it follows a path determined by how quickly it uses its fuel. Some stars move through this process quickly, while others continue almost unchanged for periods that extend far beyond ordinary experience. Holding this in mind allows a clearer understanding of the variety of stars that exist. Each one follows the same general principles, yet their differences in mass create a wide range of lifespans and behaviors. This quiet variation forms part of the larger pattern of stars across the universe, where each one continues its steady process across long stretches of time. Imagine now noticing that not all stars appear the same when viewed from a distance. Some seem to glow with a soft reddish tone, while others appear more white or even slightly blue. This difference in appearance is not random. It reflects a deeper property of the star, one that is directly connected to temperature. The color of a star is closely linked to how hot it is at its surface. Stars that appear blue or bluish-white are hotter, while those that appear red are cooler by comparison. This does not mean that red stars are cold in the usual sense. Even the cooler stars are still extremely hot, far beyond anything that can be experienced directly. Yet the difference in temperature changes the color of the light they produce. To understand this more clearly, it can help to think of heated material that changes color as it becomes hotter. As temperature increases, the color shifts gradually, moving from deeper tones toward brighter and lighter ones. In a similar way, the surface of a star emits light that reflects its temperature, creating a visible difference between stars of different heat levels. Blue stars are among the hottest. Their surfaces reach very high temperatures, causing them to emit light that appears more energetic and intense. This light carries more energy and moves at shorter wavelengths, which gives it a bluish appearance. These stars often burn their fuel quickly, producing a strong and steady output that can be seen across great distances. Red stars, on the other hand, have cooler surfaces. Their light is less intense in terms of energy, and it appears at longer wavelengths, giving it a reddish tone. These stars release energy more slowly, maintaining a steady output over long periods. Their lower temperature allows them to remain stable for extended spans of time, continuing their gradual process without rapid change. Between these two extremes, there are many variations. Some stars appear white, others slightly yellow, each representing a different temperature range. The Sun, for example, is often described as a yellow star, although its light appears white when observed directly. This places it between the hotter blue stars and the cooler red stars, reflecting its moderate surface temperature. These differences are part of a system used to classify stars, known as spectral classification. In this system, stars are grouped based on their temperature and the characteristics of the light they produce. Each group represents a range of temperatures, creating an ordered way to understand the variety of stars that exist. This classification is not only based on color, but also on the way light interacts with the elements present in the star. As light passes through the outer layers, certain patterns can be observed, revealing information about the star's composition and temperature. These patterns provide a way to study stars without needing to travel to them. Even though these differences may appear subtle when looking at the night sky, they represent meaningful variations in how stars function. Temperature influences how energy is produced and released, affecting everything from brightness to lifespan. A hotter star behaves differently from a cooler one, even if both appear as simple points of light from a distance. It can help to imagine a range of steady heat sources, each operating at a different level of intensity. Some release energy more quickly, while others do so more gradually. In each case, the temperature determines how the energy moves and how it appears when observed from afar. As you continue to observe the night sky in this way, the colors of stars become more than visual differences. They become indicators of the conditions within each star, offering a way to understand what is happening at great distances. Each color reflects a balance of temperature and energy, revealing part of the larger pattern that connects all stars. Holding this in mind, it becomes easier to see that the night sky is not uniform. Each point of light carries its own characteristics, shaped by temperature and internal processes. These variations form a quiet pattern across the sky, where color and brightness together provide insight into the nature of each star. Imagine now looking up at the night sky and noticing that some stars appear brighter than others, while some are faint and difficult to see. This difference in brightness may seem simple at first, yet it reflects two separate ideas working together. One is how much light a star actually produces, and the other is how far that light has traveled before reaching you. A star that produces a large amount of energy will release more light into space, making it naturally brighter. This is known as its true brightness, which depends on its size, temperature, and internal activity. Larger and hotter stars tend to produce more energy, allowing their light to spread outward across great distances while still remaining visible. At the same time, distance plays an equally important role. Even a very bright star can appear faint if it is far away, while a less powerful star can appear bright if it is closer. The light from each star spreads outward in all directions, becoming more spread out as it travels. By the time it reaches Earth, only a small portion of that light remains concentrated enough to be seen. This can be pictured as a steady source of light that becomes less intense as it moves outward. Near the source, the light feels strong and concentrated. As it spreads across a larger area, it becomes more diffuse, covering more space, but with less intensity in any one place. In the same way, the brightness of a star, as seen from Earth, depends on how spread out its light has become during its journey. Some stars appear especially bright in the night sky because they are both relatively close and naturally luminous. Sirius is one example, often recognized as the brightest star visible from Earth. Its brightness comes from a combination of its energy output and its distance, allowing its light to arrive in a more concentrated way compared to other stars. Other stars may be closer but less powerful, or more powerful but farther away, creating a wide range of brightness levels. This variation gives the night sky its uneven appearance, where some stars stand out clearly while others remain faint and subtle. Each point of light represents a balance between how much energy is produced and how far that energy has traveled. Distance also changes how we understand what we are seeing. The light from a star does not arrive instantly. It travels across space at a constant speed, taking time to reach Earth. For nearby stars, this journey may take only a few years, while for more distant stars it can take much longer. Because of this, looking at a star is not the same as seeing it in the present moment. Instead, you are seeing it as it was when the light began its journey. The greater the distance, the further back in time you are looking. This creates a connection between distance and time, where space becomes a way of viewing the past. Alpha Centauri, one of the closest star systems to Earth, provides a useful example of this idea. The light from this system takes a few years to reach us, meaning it is seen as it was several years ago. For more distant stars, the delay becomes much longer, extending into thousands or even millions of years. This relationship between brightness and distance allows astronomers to estimate how far away stars are. By comparing how bright a star appears with how bright it is known to be, it becomes possible to understand the scale of its distance. This process helps map the structure of space, revealing how stars are distributed across vast regions. It can be understood as observing a light from far away and estimating how distant it must be based on how faint it appears. A brighter light suggests closeness or high energy, while a dimmer one suggests greater distance or lower output. By combining these ideas, a clearer picture of the star's position can be formed. As you continue to observe the night sky with this in mind, the differences in brightness begin to take on new meaning. Each star's appearance reflects both its internal energy and its distance from Earth. What seems like a simple variation in light becomes a deeper indication of scale, distance, and the passage of time. Holding this idea allows the night sky to be understood not just as a collection of lights, but as a layered view of space and time. Each star represents a point where energy has traveled across vast distances, arriving after long periods of movement. The brightness you see is a combination of how much energy was released and how far it has journeyed to reach you. Imagine now that you are no longer looking at a single star, but at a system where two stars exist together, moving in relation to one another across space. Instead of a single point of light, there are two sources, each influencing the other through gravity. Although they may appear as one from a great distance, they are often part of a pair, connected by a shared motion that continues over long periods. In many cases, stars are not alone. A large number of them exist in what are known as binary systems, where two stars orbit around a common center. This motion is steady and continuous, with each star following a curved path, shaped by the gravitational pull of the other. rather than one star remaining fixed while the other moves. Both are in motion, responding to the same central balance. To picture this, it can help to imagine two objects connected through an invisible link, each moving in a smooth path around a point between them. The center of this motion does not belong to one star alone. Instead, it lies somewhere between them, depending on how much mass each one has. The larger star may move less, while the smaller one follows a wider path, yet both remain part of the same system. As this motion continues, the stars maintain a steady rhythm. They do not drift apart or collapse into each other under normal conditions. Their movement is balanced, with gravity pulling them together while their motion carries them forward. This creates a repeating pattern, where each star follows the same path again and again across long stretches of time. Some systems include more than two stars. In these cases, 3 or more stars move in complex arrangements, each influenced by the gravity of the others. These multi-star systems can appear more complicated, yet they still follow the same underlying principle, where motion and gravity work together to maintain structure. Beyond individual systems, stars can also be found in larger groups known as clusters. These clusters form when many stars are created within the same region of space, often from the same cloud of gas. Because they share a common origin, they remain loosely connected, moving together through space as a group rather than as isolated objects. Within a cluster, the stars are not tightly bound in the same way as binary systems. Instead, they exist in a shared region, each following its own path while still being part of the larger group. Over time, these stars can drift slightly, yet the cluster remains recognizable as a collection of stars that form together. It can be understood as a gathering of many objects within a wide area, each moving in its own direction while still remaining part of a larger structure. The connections are not as direct as in a binary system, but they are still present, shaped by the shared history of their formation and the influence of gravity. Gravity continues to guide all of these systems, whether they involve two stars or many. It acts across distance, shaping the paths of stars and maintaining their relationships over time. Even though the distances between stars can be large, gravity remains strong enough to influence their motion in a steady and predictable way. As you hold this in mind, it becomes easier to see that stars are not simply scattered randomly across space. Many are connected through shared motion, forming systems and groups that move together. What appears as a quiet arrangement of distant lights is often part of a structured and active system, where each star plays a role within a larger pattern. Looking at the night sky with this perspective reveals that some of the points of light you see may actually represent more than one star. Even though they appear as a single source from a distance, they may be part of a pair or a group, moving together in ways that are not immediately visible. This adds another layer of understanding to what is being observed. Each point of light may carry its own internal structure, shaped by relationships that extend beyond what can be seen directly. These systems continue their motion quietly, following paths set by gravity and sustained across long periods. In this way, stars can be understood not only as individual sources of light, but as parts of larger systems. Whether in pairs, small groups, or clusters, They remain connected through motion and gravity, forming patterns that extend across space while maintaining a steady and balanced presence. Imagine watching the night sky over a very long stretch of time, far longer than a single evening, where the positions of the stars begin to shift slowly. The patterns that seem fixed at first begin to change, not suddenly, but in a gradual and continuous way. This movement is known as proper motion, and it reflects the fact that stars are not standing still, but are traveling through space along their own paths. Consider how this motion would appear if it could be observed directly. Each star would be moving at a steady pace, covering great distances over time, yet the scale of those distances is so large that the movement becomes almost invisible when viewed over short periods. From one night to the next, the positions seem unchanged, giving the impression of a stable and fixed arrangement. Think of a distant object moving across a wide landscape, where the movement is so slow and the distance so great that it appears nearly motionless. Only after a long period does the change become noticeable. In the same way, stars move continuously, but their motion is spread across such vast distances that it takes years, or even centuries, for the shift to become clear. At the same time, the patterns formed by stars, known as constellations, create familiar shapes in the sky. These shapes are not physical groupings of stars, but visual patterns created from a particular point of view. The stars that form a constellation may be very far from one another, yet they appear connected because of how they align when seen from Earth. A useful way to understand this is to picture objects placed at different distances, arranged so that they appear to form a shape when viewed from one position. If the viewing position changes, the shape begins to shift. In the case of constellations, the shape remains stable only because the stars are so far away that their movement is not easily noticed over short periods. From this point, it becomes clear that constellations are not permanent structures. They are temporary arrangements that change slowly as stars move along their paths. Over long spans of time, the shapes that are familiar today will gradually transform into new patterns, even though the stars themselves continue their steady motion. Looking more closely at one particular star can help ground this idea. Polaris, often called the North Star, appears almost fixed in the sky. It holds a steady position while other stars seem to move around it. This effect is not because Polaris is completely still, but because of its position relative to Earth, making its motion less noticeable in comparison. Within this setting, Polaris has been used for navigation for long periods. Travelers have relied on its steady position to determine direction, using it as a reference point in the night sky. The consistency of its position provides a sense of stability, even though it is also part of the larger system of moving stars. In contrast to this apparent stillness, other stars show more noticeable motion when observed over long periods. Their paths carry them across the sky, slowly altering the patterns that define constellations. This movement is not random, but guided by the structure of the galaxy, where each star follows a path shaped by gravitational forces. A different way to picture this is to imagine many objects moving within a large space, each following its own path while still being influenced by a shared structure. Some move in similar directions, while others follow different paths, yet all remain part of a larger system that gives their motion a sense of order. Beyond individual motion, stars can also be grouped into larger formations, such as star clusters, which share a common origin. These groups move together through space, maintaining a loose connection over time. Even within these groups, each star still follows its own path, creating a layered sense of movement. As this motion continues, the night sky becomes less like a fixed picture and more like a slow and evolving scene. The positions of stars change gradually, the shapes of constellations shift, and the sense of permanence gives way to a quiet and steady transformation that unfolds over long periods. Holding this idea in mind allows the night sky to be understood as something dynamic rather than still. Each point of light is part of a continuous journey, moving through space while maintaining a balance shaped by gravity and motion. What appears calm and unchanging is actually part of a larger process that is always in motion, even if that motion is not immediately visible. Imagine now standing beneath the night sky with a sense of scale that extends far beyond what can be seen at first glance. The points of light above you may appear small and similar, yet each one represents an object with its own size, some far larger and some far smaller than the sun. What appears uniform from a distance is in reality a wide range of sizes that stretch across an almost unimaginable scale. Consider beginning with the smallest stars, which are only slightly larger than planets like Jupiter. These stars still produce light through fusion, yet their size remains compact compared to others. If one of these smaller stars were placed where the sun is, it would not fill the sky in the same overwhelming way, yet it would still provide a steady source of light and heat, maintaining its structure through the same internal balance. Now shift your attention toward larger stars, where the difference becomes more noticeable. Some stars grow to sizes that extend far beyond the sun, expanding outward to occupy a much greater region of space. Their outer layers spread over vast distances, creating a structure that is far larger than anything familiar in everyday experience. To bring this into perspective, imagine replacing the sun with a star like Betelgeuse. If it were positioned at the center of our solar system, its outer layers would stretch outward beyond the orbit of Mars, and possibly even further. The space that is currently occupied by several planets would instead be filled with the outer regions of this single star, showing how large such a structure can become. If you were able to observe this directly, the sense of scale would be difficult to process. The distance from the center to the outer edge would span millions of kilometers, with layers of gas extending outward in all directions. Moving through this space would not feel like crossing a surface, but like passing through a vast, diffuse region where the material becomes thinner the further you move from the center. At the same time, there are stars that fall between these extremes, forming a wide range of sizes across the universe. Some are only a little larger than the sun, while others grow to many times its size. This variation creates a continuous spectrum where no single size defines what a star must be. Think of this range as a gradual expansion from smaller to larger forms, where each step represents an increase in scale rather than a sudden jump. The smallest stars maintain a compact structure, while the largest extend outward across enormous distances, yet all follow the same basic principles of gravity and energy balance. As this range becomes clearer, It helps to connect size with other properties. Larger stars often produce more energy and have more extended outer layers, while smaller stars release energy more slowly and remain more compact. The structure of a star is closely tied to how it behaves, linking size with temperature, brightness, and lifespan. If you were to remain beneath the sky and imagine watching these stars over long periods, the difference in scale would begin to shape how each one is understood. Some would feel concentrated and contained, while others would seem vast and extended, occupying space in a way that changes how their presence is perceived. Picture standing in one place and gradually becoming aware that each point of light represents something entirely different in size. What once seemed like a uniform field begins to separate into a layered understanding, where some stars are compact and others are enormous, even though they appear similar from a distance. Within this setting, the idea of size becomes less about what is seen and more about what is understood. The true scale of each star is hidden by distance, yet it can be revealed through careful observation and comparison. This creates a deeper awareness of the diversity that exists among stars. Holding this in mind allows the night sky to be seen in a new way. Each point of light is no longer just a distant object, but a structure with its own scale and presence. Some are small and compact, while others extend outward across vast regions, all existing within the same larger system. In this way, the size of stars adds another layer to understanding the universe. What appears simple at first becomes more complex as the differences are revealed, showing that even the smallest point of light can represent something immense, shaped by forces that act across distances far beyond ordinary experience. Imagine now moving closer to the outer region of a star, not to a solid surface, but to a layer where the light finally becomes visible and begins its journey outward into space. This region is known as the photosphere. It is the part of the star that can be seen from a distance, where the energy that has traveled from deep within is released as visible light. Consider what this surface would be like if it could be experienced directly. It would not feel like standing on something firm, but more like being surrounded by an intensely bright and heated layer of gas. The material here is still moving, shifting slowly, with patterns that form and change across the surface. The light you see from a star originates from this region, carrying with it the energy produced deep in the core. Think of the energy that reaches this outer layer as having traveled a long and gradual path. It began at the center, moving outward step by step, interacting with the surrounding material, before finally reaching a point where it can escape freely. By the time it leaves the photosphere, it has completed a long journey, even though it appears as a steady and continuous glow. Beyond visible light, stars release energy across a range of forms known as electromagnetic radiation. This includes types of energy that cannot be seen directly, such as ultraviolet and infrared. These forms of energy behave in similar ways, spreading outward through space, even though they are not visible to the eye. Together, they represent a broader range of energy being released by the star. A useful way to understand this is to imagine different kinds of warmth and light that extend beyond what can be seen. Some forms carry more energy, while others are more subtle, yet all are part of the same process of energy, moving outward from the star. The visible light is only one part of this larger flow. Within this outer region, Magnetic fields also play an important role. These fields form as a result of movement within the star, creating areas where the behavior of the gas is influenced in different ways. The material near the surface does not remain perfectly uniform. Instead, it forms patterns shaped by both motion and magnetic forces. Looking more closely, certain areas of the surface appear darker than others. These are known as star spots. Even though they are still very hot, they are slightly cooler than the surrounding regions, making them appear less bright. These spots form where magnetic activity affects the movement of gas, creating localized changes in temperature. Imagine observing a bright surface where small regions appear slightly dimmer, not because they lack energy entirely, but because they are cooler in comparison to the surrounding area. These variations are part of the natural behavior of the star's surface, showing that even a steady source of light contains subtle differences. As this activity continues, the surface of the star remains dynamic, with patterns forming and changing over time. The light that reaches you is not from a completely uniform surface, but from a region that is constantly shifting in small ways. These changes are gradual, yet they reflect the ongoing processes taking place beneath the surface. If you were able to remain near this region over a long period, you would notice that the brightness is steady overall, even though small variations occur. The surface maintains a balance, continuing to release energy outward while adjusting to the internal motion and magnetic activity within the star. Holding this in mind allows the outer layer of a star to be understood not as a simple surface, but as a boundary where energy transitions from being contained within the star to moving freely through space. It is the point where the internal processes become visible, connecting what happens deep inside with what can be observed from far away. In this way, the photosphere represents a meeting point between the interior and the surrounding space. The energy that has been produced and carried outward finally reaches a stage where it can travel across the universe. The light you see is the result of this long and continuous process, emerging from a surface that is active, structured, and constantly in motion. Imagine now shifting your attention from the light that leaves a star to the material that exists within it, the substance that gives the star its structure and allows its internal processes to continue. Even though a star appears as a steady source of light, it is made of specific elements, arranged in a way that changes slowly over time. Understanding this composition reveals how stars are connected to everything around us. Consider beginning with the simplest elements, hydrogen and helium, which make up the majority of a star. These elements are present from the earliest stages of the universe and form the basic building blocks of stellar material. Within a star, hydrogen exists in vast amounts, moving freely in a heated state, while helium forms gradually as hydrogen atoms combine through fusion. Think of this process as a steady transformation that takes place deep within the star. Hydrogen is continuously being used as fuel, combining under pressure and temperature to form helium. This change is not sudden or uneven. It unfolds gradually, with each reaction contributing to the overall structure of the star and the energy it produces. As this transformation continues, new elements begin to form under certain conditions. In more advanced stages of a star's life, heavier elements can be created through further fusion processes. These elements include carbon, oxygen, and others that are not present in the earliest stages of the star's existence. Each new element forms as a result of increasing pressure and temperature within the star's core. To understand this more clearly, imagine layers within the star where different processes take place. The outer layers remain composed mostly of lighter elements, while deeper regions become sites of more complex transformations. The deeper the layer, the more intense the conditions, allowing heavier elements to form gradually over time. Now consider an idea that connects this process to something familiar. The iron found within the human body, along with many other elements present on Earth, was formed within stars. At some point in the past, these elements were created deep within stellar interiors and later released into space, becoming part of the material that formed planets and living systems. Picture this as a long chain of transformation, where material moves from one stage to another across immense spans of time. The elements that now exist on Earth were once part of stars, shaped by the same processes that continue to occur throughout the universe. This creates a direct connection between the composition of stars and the material found in everyday life. Another way to understand the composition of stars is through the light they produce. As light moves outward from a star, it carries information about the elements present within it. When this light is observed carefully, certain patterns appear, revealing which elements are present and how they are arranged. These patterns can be thought of as signatures, where each element leaves a distinct mark within the light. By studying these patterns, it becomes possible to understand the composition of a star without needing to travel to it. The light acts as a messenger, carrying detailed information across space. Looking more closely at this idea, the light from a star passes through its outer layers before reaching space. During this process, certain wavelengths are absorbed or altered by the elements present. This creates a pattern that can be observed and analyzed, allowing scientists to identify the materials within the star. Within this setting, the composition of a star is not hidden, even though the star itself is far away. The information is present within the light, waiting to be interpreted. This makes it possible to study stars in detail, understanding their structure and composition through careful observation. As this understanding develops, it becomes clear that stars are not only sources of light, but also places where elements are created and transformed. They serve as environments where simple materials are gradually turned into more complex ones, shaping the composition of the universe over time. Holding this idea in mind reveals that the material found within a star is part of a much larger cycle. Elements are formed, released, and eventually become part of new stars, planets, and systems. This continuous process connects stars to everything that exists, forming a chain that extends across space and time. Imagine now following a star as it reaches the later stages of its existence, where the steady balance that has held it together for so long begins to change. For much of its life, the star has maintained a stable relationship between gravity pulling inward and energy pushing outward. As the fuel in its core becomes less available, this balance begins to shift in a gradual but meaningful way. Consider what happens as hydrogen in the core becomes limited. The process of fusion slows in that central region, reducing the outward pressure that once balanced gravity. Without the same level of support from within, gravity begins to pull the material inward more strongly, causing the core to contract and become denser over time. As the core contracts, the temperature rises again, creating conditions that allow new types of fusion to begin. At the same time, the outer layers respond differently. Instead of moving inward, they begin to expand outward, creating a much larger and more diffuse structure. The star enters a phase where its outer regions extend far beyond their original position. Picture this as a shift where the center becomes tighter and more concentrated, while the outer layers spread outward into space. The star takes on a new form, with a dense core and an extended outer region. This stage can last for a period, with the star continuing to release energy in a different way than before. As these changes continue, the star approaches a point where its structure can no longer remain stable. In larger stars, this leads to a dramatic event known as a supernova. The outer layers are no longer held in place, and the star releases a vast amount of energy outward in a short period of time. To understand the scale of this event, imagine a single star suddenly releasing more energy than an entire galaxy of stars would produce over the same moment. The brightness increases rapidly, and the star can briefly outshine everything around it. The energy moves outward in all directions, carrying material far into space. If you were able to observe this from a distance, the change would appear sudden compared to the long life that came before it. After millions or billions of years of steady behavior, the star reaches a point where its structure gives way, releasing its outer layers in a powerful outward movement. This release of material carries elements that were formed deep within the star. Heavier elements, created through fusion, are pushed outward into the surrounding space. These elements do not disappear. They become part of the material that will later form new stars, planets, and other systems. The core that remains after this event depends on the original size of the star. In some cases, it collapses into an extremely dense object, while in others, it may continue in a different form. What remains is shaped by how much material the star contained and how its internal processes unfolded. Think of this moment as a transition, where the star changes from a stable system into something new. The outward release of energy and material marks the end of one stage and the beginning of another. The star is no longer the same as it was before, yet its influence continues in a different form. Even though this process involves a sudden release of energy, it is part of a larger cycle that unfolds over long periods. The material that is released does not remain isolated. It spreads through space, becoming part of the environment where new stars can eventually form. Holding this in mind allows the end of a star's life to be understood not as a final point, but as a transformation. The energy and material that were once contained within the star are redistributed, continuing the broader pattern that connects all stars across time. In this way, the life of a star includes not only its long period of stability, but also the moment when that stability changes. The release of energy and material adds to the ongoing cycle of formation and transformation, linking each generation of stars to those that follow. Imagine now focusing on what remains after a massive star has released its outer layers, where the central region collapses inward under the pull of gravity. Instead of spreading outward, this remaining core becomes smaller and denser, compressing into a form that is unlike anything found in ordinary conditions. The result is what is known as a neutron star, an object where matter has been packed into an extremely compact space. Consider what this level of compression means in physical terms. The material that once formed a large star is now confined to a region only a small fraction of its original size. The atoms that once existed as separate structures are forced so close together that their usual arrangement changes. The space between particles is greatly reduced, creating a form of matter that behaves very differently from what is experienced on Earth. Think of this as a gradual but powerful inward movement, where everything is drawn toward the center and compressed into a tightly packed structure. The result is a dense object where a large amount of mass is contained within a relatively small volume. The outer appearance may seem quiet and stable, yet the internal conditions are extremely intense. To bring this into perspective, imagine taking a very small portion of this material, no larger than a teaspoon, and placing it in your hand. The weight of that small amount would be far greater than anything encountered in everyday life, reflecting the extreme density of the material. Even though the size is small, the amount of mass contained within it is immense. Within this compact structure, the particles are arranged in a way that creates a stable but unusual form of matter. The forces that act within the neutron star hold it together, preventing further collapse under normal conditions. The balance that existed in the original star has shifted into a new form, where density and pressure define the structure rather than extended layers of gas. As the neutron star forms, it can begin to rotate at a very high speed. The collapse that creates it also causes its rotation to increase, similar to how an object spins faster as it becomes more compact. This rotation can become extremely rapid, with the neutron star completing a full turn in a very short amount of time. If you were able to observe this rotation directly, it would appear as a steady and repeating motion, occurring far faster than anything seen in larger objects. The surface does not appear blurred or chaotic, but moves with a consistent and controlled speed, maintaining its structure even under these conditions. In some cases, neutron stars emit beams of energy from their poles. As the star rotates, these beams sweep across space in a regular pattern. When one of these beams passes in the direction of Earth, it can be detected as a repeating signal. These objects are known as pulsars, and their signals arrive at steady intervals, reflecting the rotation of the neutron star. A useful way to picture this is to imagine a beam of light rotating in a circular motion, passing across a fixed point again and again. Each time the beam aligns with that point, it creates a signal that can be observed. The regular timing of these signals provides insight into the motion of the neutron star and the stability of its rotation. Despite the extreme conditions within a neutron star, it remains a stable object over long periods. The forces that hold it together create a balance that prevents further collapse, allowing it to exist as a compact and enduring structure. Its presence represents one possible outcome of the life cycle of a massive star. As you hold this image in mind, the idea of a neutron star becomes less abstract and more grounded in physical terms. It is a place where matter has been compressed into a dense and compact form, where rotation and energy continue to shape its behavior long after the original star has changed. This stage is not separate from the earlier life of the star, but a continuation of it, in a different form. The material that once existed in a wide and extended structure is now contained within a much smaller region, yet it continues to follow the same fundamental principles of gravity and balance. In this way, a neutron star can be understood as a transformation rather than an ending. It carries forward the mass and energy of the original star, reshaped into a form that reflects the conditions created during its collapse. Even in this compact state, it remains part of the larger system of stars, continuing its steady presence across long stretches of time. Imagine now turning your attention outward, beyond individual stars and their final stages, to the larger structure they are part of. The stars you see in the night sky are not scattered randomly. They belong to a vast system known as a galaxy, a collection of stars, gas, and dust bound together by gravity, moving as part of a shared structure across space. Consider the galaxy that contains the Sun, known as the Milky Way. It extends far beyond what can be seen with the eye alone, forming a wide, flattened shape with a central region that contains a dense concentration of stars. From within this structure, the night sky appears filled with points of light. Yet these points are part of a much larger arrangement that stretches across immense distances. Think of this structure as a broad disk, where stars are spread across a vast plain, with some regions more densely populated than others. The center contains a greater concentration of stars, while the outer regions become more spread out. This difference in density creates a sense of depth, where the number of stars increases as you look toward the central region. At the same time, the stars within the galaxy are not fixed in place. Each one is moving along its own path, guided by the combined gravitational influence of the entire galaxy. The Sun itself is traveling through this structure, moving along a steady path that takes it around the center of the Milky Way over long periods. To understand this motion more clearly, imagine being within a vast system where everything is slowly moving in a coordinated way. The movement is not noticeable over short periods, yet it continues steadily across millions of years. Each star follows its own path, yet all are part of the same larger motion that defines the structure of the galaxy. A useful way to picture this is to imagine a wide and gently rotating system, where objects move along curved paths around a central region. The motion is smooth and continuous, with no sudden changes, creating a stable pattern that repeats over long stretches of time. The galaxy maintains its shape through this shared movement, even as individual stars follow their own paths. Within this setting, the distance between stars is vast. Even though the night sky appears crowded, the space between stars is enormous. If one star were placed close to another, in comparison to everyday distances, it would still be separated by a region so large that it would feel mostly empty. This sense of scale is difficult to fully grasp, yet it is a defining feature of the galaxy. Picture standing in a wide open space where each point of light is separated by distances far greater than anything experienced on Earth. The emptiness between them is part of the structure, allowing stars to move freely without constant interaction. The galaxy is not a dense cluster where objects are tightly packed, but a system where distance plays a key role. As you continue to consider this structure, it becomes easier to understand that the galaxy contains not just stars, but also gas and dust that move within it. These materials form clouds that can later become new stars, continuing the cycle that has taken place over long periods. The galaxy is not static, but constantly evolving as material shifts and changes within it. Looking more closely toward the center of the Milky Way reveals a region of greater activity and density. Stars are more closely grouped, and the gravitational forces are stronger. This central region influences the motion of the rest of the galaxy, acting as a point around which the entire system is organized. If you were able to observe the galaxy from far outside, it would appear as a large, structured system with a clear shape, yet from within it feels like a vast and open environment filled with distant points of light. The perspective changes how the structure is perceived, even though the underlying arrangement remains the same. Holding this image in mind allows the night sky to be understood as part of a much larger system. Each star you see belongs to a galaxy that extends far beyond what can be directly observed. The motion, distance, and structure all contribute to a larger pattern that connects individual stars into a unified whole. In this way, the study of stars naturally expands into the study of galaxies. What begins as a single point of light becomes part of a vast system where countless stars move together across immense distances. The Milky Way represents one example of this structure, containing the sun and the stars that fill the night sky, all part of a continuous and evolving system. Imagine now stepping back from everything you have been considering, not just from a single star, but from the entire region of space that contains it. Allow that distance to increase slowly, as if you are moving outward in a steady and continuous way, leaving behind the familiar view of the night sky and entering a wider perspective where individual stars begin to blend into a larger structure. At first, the stars still appear distinct, scattered across space in every direction. The sun remains one among many, and the surrounding stars continue to form patterns that feel familiar. As the distance increases further, those individual points of light begin to gather visually into a band, a soft and continuous glow that stretches across the view. This is the larger structure of the Milky Way, seen not from within, but from a position that reveals its full shape. From this perspective, the galaxy is no longer just a background of scattered light. It becomes a defined structure, wide and gently curved, with a central region that appears brighter and more concentrated. The outer regions extend outward in a flattened form, creating a shape that resembles a broad disk. The stars that once seemed separate are now clearly part of a single system, connected through gravity and motion. Now allow the distance to increase even more. The Milky Way begins to shrink, its vast size gradually becoming more manageable within your view. The countless stars within it blend into a single luminous form, and the details of individual regions begin to fade. What was once a complete and overwhelming system becomes just one object among many others that begin to appear around it. At this point, something important begins to change. The Milky Way is no longer the dominant structure in your view. Instead, other galaxies become visible, each one similar in scale, each one containing its own billions of stars. They appear scattered across space, yet not in a completely random way. There is a sense of spacing, of distance, of structure beginning to reveal itself. Pause here for a moment and imagine what this truly represents. Every one of those distant points is not a single star, but an entire galaxy, containing systems as vast as the Milky Way. The number of stars within each one extends far beyond what can be counted in ordinary terms. What once felt immense now becomes one example among many. As you continue to move outward, these galaxies begin to gather into groups. They are not evenly spaced, but tend to cluster together, forming regions where many galaxies exist within the same area of space. These galaxy clusters create a new level of structure, where entire systems are bound together by gravity, moving slowly in relation to one another. Picture this as a wide region, where large luminous forms are suspended within space, each one maintaining its own structure, while also participating in a shared motion. The distances between them are still vast, yet within a cluster, they are closer to one another than to galaxies beyond that region. This creates a sense of grouping, where patterns begin to emerge at a larger scale. Now extend your awareness even further. These clusters themselves are not isolated. They connect to other clusters, forming even larger arrangements known as superclusters. At this level, the structure of the universe begins to resemble something more intricate, where clusters form long chains and wide regions that stretch across immense distances. A useful way to picture this is to imagine a vast network, where points are connected by extended pathways, forming a pattern that spreads outward in every direction. The universe at this scale begins to resemble a kind of cosmic web, where galaxies and clusters are the denser regions, and the space between them forms wide, open areas that stretch across unimaginable distances. If you could remain in this position and observe over a long span of time, the motion within this structure would still be present. Galaxies would drift slowly within clusters, clusters would shift within superclusters, and the entire system would continue its gradual evolution. The movement would not feel sudden or chaotic, but steady and continuous, unfolding over periods far beyond everyday experience. Now allow yourself to pause again and take in the full scale of what you are observing. Each galaxy contains billions of stars. Each of those stars may have its own system, its own surrounding space, its own history. The number of individual objects within this view becomes so large that it is difficult to hold in mind all at once. At the same time, the space between these structures is not entirely empty. It contains faint material and energy, spread thinly across vast regions. This background presence contributes to the overall structure, even though it is not easily seen. The universe is not simply a collection of isolated objects, but a continuous system where both dense regions and wide spaces play a role. Now consider the connection between distance and time once more. The light from these distant galaxies has traveled for immense periods before reaching this point of observation. Some of that light began its journey millions of years ago, while other light has traveled for billions of years. Looking outward becomes a way of looking into the past. Imagine observing two galaxies at different distances. The closer one reflects a more recent state, while the more distant one shows a much earlier stage in the history of the universe. The further away you look, the further back in time you are seeing. This creates a layered view where different moments in time exist together within a single field of observation. Hold that idea for a moment. What you are seeing is not just space, but a combination of space and time. Each point of light carries with it a history, a record of what existed when that light began its journey. The universe becomes a place where the past is still visible, carried forward through the movement of light. Now gently bring your attention back toward the Milky Way, recognizing it once again within this vast arrangement. It is one galaxy among many, part of a cluster, part of a larger structure that extends far beyond what can be directly observed. The stars within it, including the Sun, are part of this larger system, connected through layers of structure that continue outward without a clear boundary. As this perspective settles, the night sky takes on a different meaning. What once appeared as scattered points of light becomes part of an immense and interconnected system. Each level of structure builds upon the one before it, forming a continuous pattern that stretches across space and time. In this way, the journey from a single star to the scale of the universe reveals a pattern that is both vast and unified. The same principles that govern individual stars extend outward to galaxies, clusters, and beyond. Everything is connected through gravity, motion, and time, forming a system that continues to evolve in a steady and continuous way. Imagine now remaining at that wide and distant perspective, where entire galaxies are visible at once, suspended across an immense and quiet space. At first, everything appears still. The galaxies hold their positions, forming patterns that seem stable and unchanging. There is no immediate sense of motion, no obvious shift from one moment to the next, only a vast arrangement of light spread across an endless distance. Now allow time to begin stretching in your mind, not minutes or hours, but millions of years passing in a steady and continuous way. At first, nothing appears different. The galaxies remain where they are, their shapes and positions holding steady. As more time passes, something subtle begins to change. The distance between them starts to increase, not abruptly, but in a gradual and consistent way. Stay with that image. Imagine watching two distant galaxies over a long span of time, observing the space between them. Slowly, almost imperceptibly, that space begins to widen. The galaxies do not appear to move through space in the usual sense. Instead, the space itself is stretching, carrying them farther apart without requiring them to travel across it. To understand this more clearly, picture a surface that is expanding in all directions. Points marked on that surface remain fixed to it, yet as the surface grows, the distance between those points increases. The motion does not come from the points moving independently, but from the expansion of the space that connects them. This is how the universe behaves on its largest scale. Pause here and imagine yourself positioned between galaxies, not near any one of them, but in the wide space that separates them. At first, the emptiness feels complete, with only distant light visible in every direction. As time continues to pass, the space around you becomes even more open. The galaxies drift farther away, their light growing slightly more distant, their presence still visible but gradually more separated. This is one of the anchor moments to hold on to. You are not watching objects move away from you through space. You are watching space itself expand, increasing the distance between everything that exists within it. The change is not forceful or sudden. It is steady, quiet, and continuous, unfolding across immense spans of time. Now consider how this expansion affects light. As light travels from distant galaxies toward you, it moves through space that is itself stretching. The path becomes longer as the light travels, and the light itself becomes stretched along with it. This stretching changes its properties, shifting it toward longer wavelengths in a process that can be observed. Imagine following a single beam of light as it leaves a distant galaxy. It begins its journey with a certain energy and structure, moving steadily through space. As it travels, the space it moves through slowly expands, gently pulling that light apart, stretching it over time. By the time it reaches you, it carries with it a record of that expansion. Hold that image for a moment. The light you observe is not just a signal from a distant place. It is a record of the journey it has taken, shaped by the space it has traveled through. It tells you not only where it came from, but how the universe has changed during its journey. Now shift your attention back to the galaxies themselves. As the expansion continues, the more distant galaxies appear to move away more quickly than those that are closer. This creates a pattern that connects distance with the rate of separation. The further away a galaxy is, the faster it appears to recede, not because it is moving through space more quickly, but because there is more space expanding between you and it. Picture this as layers of distance unfolding outward. Nearby galaxies drift away slowly, while those further out seem to separate more rapidly. The pattern remains consistent, forming a clear relationship that applies across the entire observable universe. This relationship allows the structure of the universe to be measured and understood. Now imagine remaining in this position over an even longer span of time. The galaxies that once filled your view begin to spread farther apart. Regions that once appeared connected begin to separate. The structure remains, but it becomes more extended, more open, more spacious. The universe does not lose its form, but it grows larger while maintaining its underlying pattern. Another anchor moment begins to form here. Imagine watching a dense region of galaxies slowly expand outward, becoming less crowded over time. The light between them stretches, the space widens, and the sense of closeness gradually fades. What once felt like a gathering becomes a more open arrangement, where distance plays a greater role. At the same time, this expansion does not affect smaller structures in the same way. Within galaxies, stars remain bound together by gravity. Within star systems, planets continue to orbit their stars. The expansion occurs on the largest scale, where the distances between galaxies are vast enough for this effect to dominate. Think of this as two different layers of behavior. At smaller scales, gravity holds systems together, maintaining their structure. At larger scales, the expansion of space increases the distance between those systems. Both processes occur at the same time, creating a balance between structure and expansion. Now return once more to the idea of time. The expansion has been taking place for an immense duration, and it continues in the present moment. The light reaching you from distant galaxies carries with it evidence of this ongoing change. Each observation reveals a small part of a much larger process that unfolds across billions of years. Allow that thought to settle. The universe is not static. It is not fixed in its arrangement. It is continuously changing, with space itself expanding, increasing the distance between the largest structures while preserving the systems within them. The motion is not something that can be felt directly, yet it is present everywhere at once. As you bring this perspective together, the universe becomes a place defined not only by its structure, but by its ongoing change. The galaxies, clusters, and superclusters are all part of a system that is gradually unfolding, shaped by the expansion of space and the passage of time. In this way, the study of stars and galaxies leads to an understanding of something even larger. The universe itself is evolving, not through sudden events, but through a steady and continuous expansion that affects everything within it. The night sky becomes not just a view of distant light, but a glimpse into a process that is still unfolding across the largest possible scale. Imagine now allowing everything you have taken in so far to settle into a single, continuous view. The stars, the galaxies, the immense distances, and the steady expansion of space all remain present at once, forming a layered sense of structure that extends in every direction. Nothing needs to be separated or analyzed in this moment. Instead, everything can be held together as part of one quiet and continuous system, where each level connects naturally to the next. Consider what it would feel like to remain in this position, not moving closer or further away, but simply observing. The galaxies remain suspended across space, their light steady and distant. The expansion continues, though it cannot be felt directly. The motion is present, yet it unfolds so gradually that it blends into stillness, creating a sense of calm rather than change. Now allow time to begin stretching in your mind, not minutes or hours, but millions of years passing in a steady and uninterrupted way. At first, nothing appears different. The galaxies hold their positions, and the patterns remain stable. As more time passes, however, the distance between them begins to increase, not suddenly, but with a quiet and consistent progression. Stay with that image and allow it to deepen. The galaxies do not move across space like objects drifting through a fixed environment. Instead, the space between them expands, gently increasing the distance in every direction. The motion is not something that happens to the galaxies themselves, but to the structure that connects them. Picture this as a vast surface that is slowly growing. Points placed on that surface remain fixed in their positions, yet as the surface expands, the distance between those points increases. The expansion happens everywhere at once, affecting all regions equally. This is the nature of the universe at its largest scale. Now imagine placing yourself within that expanding structure, not near any one galaxy, but in the wide region that exists between them. At first, the emptiness feels complete, with distant light scattered in every direction. As time continues, that emptiness grows. The galaxies move further away, their light becoming more distant, their presence still visible, but gradually more separated. Hold this as your first anchor moment. You are not drifting through space. You are not moving away from the galaxies. Instead, the space itself is expanding around you, increasing the distance between everything that exists within it. The change is not forceful or sudden. It is steady, quiet, and unavoidable, unfolding across immense spans of time. Now shift your attention to the light that continues to travel across this expanding space. Each beam begins its journey from a distant galaxy, carrying energy outward in a straight, and continuous path. As it travels, the space it moves through stretches, gently pulling that light apart over time. Imagine following that light closely. It begins with a certain structure and energy, moving steadily through space. As the distance increases, the path becomes longer, and the light itself becomes stretched. By the time it reaches you, it carries not only its origin, but the imprint of the expanding space it has traveled through. Pause here for a second anchor moment. The light you see is not simply a signal from a distant place. It is a record of the journey it has taken, shaped by the expansion of the universe itself. It tells you not only where it came from, but how the universe has changed during its travel. Now return your attention to the galaxies themselves. As the expansion continues, the more distant galaxies appear to move away more quickly than those that are closer. This creates a consistent pattern where distance and apparent motion are connected. The further away a galaxy is, the faster it appears to recede. Picture this as layers of separation unfolding outward. Nearby galaxies drift away slowly, while those further out separate more rapidly. The pattern remains smooth and predictable, forming a relationship that applies across the entire observable universe. This relationship provides a way to understand how space itself is expanding. Now imagine remaining within this expanding universe over an even longer span of time. The galaxies that once filled your view begin to spread farther apart. Regions that once appeared connected begin to open up, creating larger spaces between them. The structure remains, but it becomes more extended, more spacious, and more open. Hold this as your third anchor moment. Imagine watching a region that once felt full of galaxies slowly become less dense. The light between them stretches, the distances increase, and the sense of closeness gradually fades. The universe does not become empty, but it becomes more open, more spacious, and more widely spread. At the same time, notice something important. Within each galaxy, the smaller structures remain stable. Stars continue to orbit within galaxies, and planets continue to orbit their stars. The expansion does not break apart these smaller systems. Instead, it operates at a larger scale, affecting the distances between galaxies rather than the structures within them. Think of this as two layers existing together. On one level, galaxies move apart as space expands. On another level, stars and planets remain bound together by gravity. Both processes occur at the same time, creating a balance between expansion and stability across different scales. Now allow your attention to extend even further into the future. The expansion continues, steady and uninterrupted. Over immense periods, the distances between galaxies grow so large that fewer and fewer remain visible from any one location. The universe begins to appear quieter, not because it has changed suddenly, but because the distances have increased beyond what light can cross. Picture standing within a future galaxy, looking outward into space. The number of visible galaxies has decreased, not because they no longer exist, but because they have moved so far away that their light can no longer reach you. The sky becomes darker, more isolated, with fewer distant points of light. Hold this as your fourth anchor moment. The universe has not disappeared, but the visible portion of it has changed. What you can see depends on distance, and distance continues to grow. The view becomes more limited, even though the larger structure still exists beyond what can be observed. Now gently return your attention to the present moment. The galaxies are still visible, the structure is still connected, and the light from distant regions continues to arrive. The expansion is ongoing, but it has not yet reached the stage where the universe feels empty or isolated. Instead, it remains rich with structure and light. Allow this idea to settle. The universe is both vast and evolving, expanding continuously while maintaining its underlying structure. The motion is steady, the changes are gradual, and the patterns remain connected even as distances increase. Now bring everything together once more. The stars, the galaxies, the clusters, and the expanding space all exist as part of a single, continuous system. Nothing is separate. Each level connects to the next, forming a structure that extends outward across immense distances. In this way, the universe can be understood as something that is always in motion, even when it appears still. The expansion of space carries everything outward, increasing distance while preserving connection. The result is a structure that continues to evolve, shaped by processes that unfold quietly and steadily across the largest possible scale. As this final perspective settles, the night sky takes on a deeper meaning. What once appeared as scattered points of light becomes part of a vast and evolving system where distance, time, and structure are all connected. The universe is not fixed. It is unfolding, slowly and continuously, carrying everything within it outward across time. Imagine now returning gently through everything you have explored, not by retracing each step in detail, but by allowing the entire journey to come back into awareness as a single, connected experience. The stars, their formation, their changes over time, and their place within the larger structure of the universe all begin to settle together, forming a quiet sense of continuity rather than separate ideas. Consider beginning once more with the simplest image, a single star forming within a cloud of gas. The material gathers slowly, drawn inward by gravity, becoming denser and warmer as it comes together. Over time, this process reaches a point where energy begins to form within the core, and the star starts to shine. What once was a diffuse cloud becomes a steady source of light, beginning a long and gradual life. Now allow that image to remain while you expand your awareness slightly. The star does not exist alone. Around it, space extends outward, and other stars form in similar ways, each one following its own path, while remaining part of a larger system. The balance between gravity pulling inward and energy pushing outward maintains each star's structure, allowing it to remain stable across long periods. Think about how that balance shapes everything that follows. As long as the energy within the star continues to push outward, it holds its form, shining steadily across time. The light it produces travels outward, moving through space and eventually reaching distant locations, carrying with it the energy that began deep within the star. As this continues, the star itself begins to change. The fuel within its core is used gradually, transforming into new forms. The structure remains stable for long periods, yet beneath that stability, a slow process of change unfolds. Over time, this leads to new stages, where the balance shifts and the star takes on different forms. Picture this as a long and continuous transformation, where nothing happens suddenly, yet everything is slowly evolving. The star expands or contracts, changes its internal structure, and eventually reaches a point where its original state can no longer be maintained. What follows depends on its size, leading to different outcomes that continue the cycle. Now allow that idea to widen further. The material that forms new stars comes from earlier stars, released back into space, and gathered once again into new structures. The process is not isolated. It continues across generations, linking one stage to the next in a steady and repeating pattern. Imagine this as a quiet cycle, where material moves from one form to another without interruption. A cloud becomes a star, the star transforms, and its material returns to space, eventually forming new stars again. This process unfolds across immense spans of time, yet it remains continuous. As your awareness expands again, the stars themselves become part of something larger. They gather into galaxies, vast systems containing billions of stars moving together through space. Each star remains part of its own system, yet it also belongs to a larger structure that extends far beyond it. Picture the galaxy as a wide and gently moving system, where stars follow paths shaped by gravity. The motion is steady and continuous, unfolding over long periods. From within, it appears as a field of stars. From outside, it reveals a clear and organized structure. Now, allow that perspective to widen even further. The galaxy becomes one among many, each one containing its own collection of stars. These galaxies gather into clusters, forming larger groupings that continue to extend across space. The scale increases, yet the same underlying principles remain. Think of this as a pattern repeating across different levels. What happens within a star reflects what happens within a galaxy, and what happens within a galaxy reflects what happens across the universe. The structure changes in size, but the relationships remain connected. Now, bring time into this view once more. The light from distant stars and galaxies travels across space, carrying with it information from the past. Each point of light represents a moment that has taken time to reach you. The further the distance, the further back in time that moment began. Picture this as layers of time unfolding across space. Nearby stars reflect more recent conditions, while distant galaxies reveal earlier stages. The universe becomes a place where space and time are linked, where distance reveals history. Now allow your awareness to settle on the idea of expansion once again. The space between galaxies continues to stretch, increasing distance without requiring direct movement. The galaxies drift apart, carried outward by the expansion of space itself. Imagine this not as something dramatic, but as something steady and continuous. The distances grow slowly, the structure remains, and the overall pattern continues to unfold. The universe expands without losing its form, maintaining its connections while increasing its scale. Now begin to bring all of these ideas together. The star forming in a cloud, the steady balance of energy and gravity, the transformation over time, the gathering of stars into galaxies, and the expansion of the universe are all part of the same continuous process. There is no clear boundary between these stages. Each one leads naturally to the next, forming a chain that extends across both space and time. The smallest details and the largest structures are connected through the same underlying principles. As you hold this entire system in mind, Notice how it begins to feel less complex and more continuous. The details remain, yet they no longer need to be separated or analyzed. Everything fits together as part of a larger whole, where each part supports the others. Now allow that understanding to soften slightly. There is no need to follow every step or hold every detail. It is enough to recognize that everything you have explored forms a single connected system that continues to unfold. Picture the night sky once more, not as a collection of separate points of light, but as part of this continuous structure. Each star belongs to a larger system. Each system belongs to a galaxy, and each galaxy is part of an even greater arrangement. Let that idea remain gently present. The stars continue to shine, the galaxies continue their motion, and the universe continues to expand. Nothing needs to be added or changed. Everything is already part of the same ongoing process. As this perspective settles, the sense of distance begins to soften. The stars no longer feel isolated, and the vast scale of the universe becomes something that can be held calmly in awareness. The motion continues, yet it does not need to be followed. Now allow everything to remain as it is, steady and continuous, without needing to move forward. The journey does not end here, but it also does not need to continue. Everything that has been explored is already present, connected, and complete. From this point, you can gently move into stillness, carrying this sense of continuity with you as the stars, galaxies, and the universe itself continue quietly in the background. Now, instead of moving forward into anything new, allow everything you have just brought together to remain present for a little longer. There is no need to continue or progress. The understanding is already there, and it can simply rest, without needing to be expanded further. Imagine once more standing beneath the night sky, not as an observer trying to follow or understand, but as part of the same quiet system you have been exploring. The stars remain above, steady and unchanged in their appearance, yet now they carry a different meaning. They are no longer distant points, but part of a continuous structure that extends far beyond what can be seen. Let that feeling settle more deeply. The distance between you and the stars is still there, yet it no longer feels like separation. Instead, it becomes part of a wider connection, where everything exists within the same system, linked through light, motion, and time. Now allow your awareness to rest on the space between the stars. That space, which once seemed empty, now holds meaning as well. It is the region through which light travels, where motion unfolds, and where the expansion of the universe quietly takes place. It is not empty, but part of the same continuous structure. Picture yourself not focusing on any single star, but resting within that space itself. The stars remain present around you, yet your attention is no longer fixed on them. Instead, it rests within the stillness that connects everything together. This becomes a final anchor moment. You are not looking outward at the universe. You are resting within it, part of the same continuous presence. The stars, the galaxies, and the space between them are not separate from you in this awareness. They are all part of the same quiet system. Now remain here for a little longer than feels necessary. There is no need to move on. The stars continue their steady processes. The galaxies continue their slow motion, and the expansion continues across the larger scale. Nothing needs to be followed. Nothing needs to be understood further. As you stay within this stillness, notice how the sense of scale begins to soften. What once felt immense now feels continuous. What once felt distant now feels connected. The universe remains vast, yet it no longer feels overwhelming. It becomes something that can be held gently, without effort. Now allow even that sense of holding to fade slightly. There is no need to keep the full structure in mind. It is enough that it exists, steady and continuous, whether it is observed or not. The stars remain, the galaxies remain, and the universe continues quietly. From here, everything is ready to settle fully into stillness, where no further movement or understanding is needed, and where the transition into the final quiet of the journey can happen naturally. Imagine now allowing everything you have explored to settle into a single quiet awareness that no longer needs to move forward. The stars, the galaxies, the vast distances, and the steady expansion of space are no longer separate ideas to follow one by one. They exist together, forming a continuous presence that extends outward in every direction, without edges, without boundaries, and without urgency. There is nothing you need to focus on here. No single point is more important than another. Instead, everything can remain gently present, as if the entire universe is simply resting in place, even while it continues its slow and steady motion across time. Consider what it feels like to remain in this position, not observing with effort, but simply allowing awareness to rest within the system itself. The light from distant stars continues to arrive, just as it always has, traveling across immense distances without interruption. The galaxies remain suspended across space, their motion so gradual that it blends into stillness. Now allow your awareness to soften slightly and let it drift toward a single point of light once more. Among the countless stars, one becomes quietly familiar again. It does not stand out in brightness or size, yet it carries a sense of closeness that feels steady and calm. This is the sun, one star among many, continuing its quiet process without interruption. Picture its light moving outward, leaving its surface and traveling across space in a straight and continuous path. That light crosses the distance between the sun and the earth, arriving as warmth and brightness. The energy that began deep within its core has moved outward step by step, passing through layers, crossing space, and arriving as something that can be felt. Pause here and hold this as a gentle anchor. The same process that exists in distant stars is present in the light that reaches you. The connection is not distant, it is immediate, carried through the energy that continues to move outward in a steady and uninterrupted way. Now allow your awareness to expand again, slowly and without effort. The sun becomes one point among many, and those points form a wider pattern. The stars gather into a galaxy, a vast structure containing billions of stars moving together through space. That galaxy becomes one among many others, each one similar in scale, each one part of a larger arrangement. Imagine tracing that path outward once more, but this time more slowly, allowing each step to fully unfold before moving to the next. From the sun to nearby stars, from those stars to the galaxy, from the galaxy to clusters, and from clusters to even larger structures. Each layer expands the sense of scale, revealing something larger, while remaining connected to what came before. As you follow this path, notice how the sense of size begins to change. What once felt immense becomes small in comparison to what comes next. The galaxy that once seemed vast becomes one among many, and those many form patterns that extend across space. The expansion continues, increasing the distance between them, yet the structure remains connected. Now allow time to enter this view once more, not as something that passes quickly, but as something that stretches across immense spans. The light that reaches you from distant galaxies has traveled for millions or billions of years. It began its journey long ago, moving steadily through space until it arrived at this moment. Picture this as a layered view, where distance and time exist together. Nearby stars reflect more recent moments, while distant galaxies reveal earlier stages of the universe. The further you look, the further back in time you are seeing. The present and the past exist together within the same quiet field of awareness. Let that idea settle gently. The universe is not only vast in space, but also extended in time. Everything you observe carries with it a history, a trace of where it has been and how long it has traveled. The light does not simply arrive. It carries with it a story that has unfolded across distance. Now return once more to the idea of expansion, allowing it to deepen rather than move forward. The space between galaxies continues to stretch, increasing distance without requiring anything to move in the usual sense. The galaxies drift further apart, not because they are traveling away from one another directly, but because the space that connects them is growing. Imagine once again standing within that expanding space. At first, the galaxies are visible in every direction, forming a wide and connected pattern. As time continues, the distances increase, the space becomes more open, and the galaxies begin to appear further apart. Hold this as another anchor moment. You are not moving. The galaxies are not moving away from you in a direct way. Instead, the space around you is expanding, carrying everything outward at once. The change is quiet, steady, and continuous, unfolding across immense spans of time. Now remain here longer than before. Do not move on too quickly. Allow the sense of increasing distance to deepen. The galaxies become slightly more distant, their light slightly more separated. The space between them becomes more noticeable, more present, more open. As you stay within this moment, notice how the structure does not disappear. It stretches, it expands, but it remains. The connections are still there, expressed across larger distances. The universe becomes more spacious, but not empty. Now shift your awareness gently to the light traveling across this expanding space. Each beam begins its journey from a distant galaxy, moving steadily outward. As it travels, the space it moves through stretches, gently pulling that light apart over time. Imagine following that light closely, not rushing, but staying with it as it moves. It begins with a certain structure, a certain energy. As it travels, that structure slowly changes, stretched by the expansion of space itself. By the time it reaches you, it carries the imprint of everything it has passed through. Pause again and hold this as another anchor. The light you observe is not only a signal from a distant place, it is a record of the journey it has taken, shaped by the universe itself. It carries with it both origin and change, both distance and time. Now return your awareness to the galaxies once more. As the expansion continues, the more distant galaxies appear to move away more quickly than those that are closer. The pattern remains consistent, forming a relationship between distance and separation that applies across the entire observable universe. Picture this as layers unfolding outward. Nearby galaxies drift slowly, while those further away separate more rapidly. The pattern is smooth, continuous, and predictable, revealing something fundamental about the nature of the universe. Now allow yourself to remain in this expanded view for an even longer span of time. The galaxies that once filled your awareness begin to spread further apart. Regions that once appeared connected begin to open, creating larger spaces between them. Hold this as a deeper anchor moment. Imagine watching a region that once felt full slowly become less dense. The light between galaxies stretches, the distances increase, and the sense of closeness gradually softens. The universe does not lose its structure, but it becomes more open, more spacious, more extended. At the same time, notice something steady beneath all of this change. Within galaxies, stars continue their quiet processes. Within star systems, planets continue their steady paths. The expansion does not break these smaller systems apart. It exists alongside them, shaping the larger structure while leaving the smaller ones intact. Think of this as layers existing together. At one level, stars burn steadily, producing light and energy. At another level, galaxies move within clusters. At the largest level, space itself expands, increasing the distance between everything. Each layer follows the same underlying principles, expressed at different scales. Allow these layers to settle into a single awareness. Nothing is separate. The star, the galaxy, and the universe are all part of one continuous system. The differences are only in scale, not in the underlying process. Now allow your awareness to soften even further. There is no need to follow any single layer. The stars remain present, the galaxies remain distant, and the expansion continues quietly. Everything is already in place, moving as it always has. Picture the night sky once more, not as something separate from this larger structure, but as a direct expression of it. The points of light you see are connected to everything you have imagined, forming a link between what is visible and what extends far beyond sight. Let that connection feel simple and steady. There is no need to hold on to every detail. It is enough to recognize that everything you have explored is part of one continuous system, unfolding gradually across time and space. As you remain here, the sense of distance begins to soften. The stars no longer feel far away, and the vast scale of the universe becomes something that can be held gently in awareness. The motion continues, the light continues, and the structure remains. Now allow everything to settle into stillness. The motion is still present, but it no longer needs to be followed. The expansion continues, but it does not need to be measured. The stars remain steady, part of a system that continues without interruption. Stay here for a moment longer. There is no need to move forward or return. The universe continues, whether it is observed or simply allowed to be. The stars remain, the galaxies remain, and the expansion continues, carrying everything outward in a steady and gentle way. As this awareness settles fully, the sense of scale becomes calm rather than overwhelming. What once seemed vast now feels continuous. What once seemed distant now feels connected. The light, the motion, and the structure all remain present, part of a system that does not require effort to understand. Now, allow even that awareness to soften. There is nothing more to follow, nothing more to expand. The journey has already reached its natural resting point. The stars continue, the galaxies continue, and the universe continues, unfolding quietly across time. Now, instead of moving forward, allow everything to remain exactly where it is, without needing to change or continue. The stars remain steady, the galaxies remain distant, and the expansion continues quietly in the background, unfolding without urgency. There is no next step to follow, only a gentle continuation of what is already present. Imagine now that your awareness is no longer focused on distance or scale, but simply resting within the presence of the universe itself. The need to measure how far something is, or how large it might be, begins to soften. What remains is a quiet sense of connection, where everything exists together without needing to be compared or understood in detail. Consider what it would feel like to be beneath a night sky, not observing it as something separate, but simply allowing it to exist around you. The stars appear in their familiar positions, steady and calm, each one part of the larger system you have already explored. There is no need to identify them or follow their motion. It is enough that they are there. Now let that feeling deepen. The sky above is not distant in the way it once seemed. It is part of the same continuous structure, connected through the same processes of light and motion. The distance remains, yet it no longer feels separate. It becomes part of a wider sense of presence that includes everything at once. Allow your awareness to rest on the light itself, arriving quietly from distant stars. That light has traveled across immense distances, moving steadily through space until it reaches you. It does not arrive with force or urgency. It arrives gently, as part of a continuous flow that has always been present. Picture that light not as something that has just appeared, but as something that has been traveling for a long time, moving through space without interruption. By the time it reaches you, it carries with it a sense of continuity, a connection that extends far beyond the moment of arrival. Now allow that idea to soften further. There is no need to follow where the light came from or how long it has traveled. It is enough to recognize that it is part of a steady and ongoing process, one that continues whether it is observed or not. As you remain here, notice how the sense of motion becomes less important. The stars continue their processes, the galaxies continue their slow drift, and the expansion continues across the larger scale. Yet none of this requires attention. It unfolds quietly, without needing to be followed. Let your awareness rest within that quiet unfolding. There is no need to track distance, no need to measure time, and no need to understand every detail. The universe continues in its own way, steady and uninterrupted, whether it is observed or simply allowed to be. Now imagine the night sky once more, not as something to look at, but as something to rest within. The points of light remain, steady and calm, forming patterns that do not need to be named or followed. The vastness remains, yet it no longer feels overwhelming. It feels continuous, extending outward without pressure. Allow that sense of continuity to deepen. The stars, the galaxies, and the space between them all exist as part of the same quiet system. There is no separation between them, only different expressions of the same underlying structure. Now let even that awareness begin to soften. There's no need to hold on to the idea of structure, or scale, or distance. The universe does not require explanation in this moment. It is enough that it continues, steady and present. Imagine remaining here without any need to move forward or return. The light continues to arrive. The stars continue their quiet processes, and the expansion continues across the largest scale. Everything remains in place, unfolding gradually across time. As this stillness deepens, the sense of distance fades even further. The stars no longer feel far away, and the vast scale of the universe becomes something that can be held gently, without effort. The motion is still there, but it no longer needs to be followed or understood. Now allow everything to settle completely. The movement continues, but it blends into stillness. The light continues, but it requires no attention. The structure remains, but it does not need to be explored further. Stay here for a moment longer, allowing the quiet presence of the universe to remain exactly as it is. The stars continue, the galaxies continue, and the expansion continues, all part of a steady and uninterrupted system. Thank you for listening to the Sleepy Mind channel. I hope you enjoyed learning about stars.